Hi, seventh graders. Today we're taking a look at page 87 in your book, and it's lesson 7, Understanding Equations. And what the target goals are for today is that you'll know that an equation is a statement of equality between two expressions. And you'll also be able to build an algebraic expression using the context of a word problem, and then use that expression to write and solve an equation. Now, just a reminder really quick, what is a variable? Yeah, it's just a letter that represents an amount, right? So it's an X, a Y, a Z, any letter that you choose. What's the difference between an equation and an expression? Awesome. An equation has that equal sign. An expression does not. Give an example of a number sentence. What's a number sentence? Yeah, it's absolutely anything like 4 plus 3 is 7. That's a number sentence. What is a solution to an equation? Yep, a solution just makes something true. So as long as it becomes true, it's a solution. All right, first problem says, your brother is going to college, so you no longer have to share a bedroom. You decide to redecorate a wall by hanging 2 new posters on the wall. The wall is 14 feet wide, and each poster is 4 feet wide. You want to place the posters on the wall so that the distance from the edge of each poster to the nearest edge of the wall is the same distance as between the posters. As shown in the diagram below, determine the distance. So you can see the diagram, and we need to figure out how far it's going to be, right? So let's go ahead and take a look at it. Ready? So we have our posters labeled. They're 4 feet each, and I have 14 feet up at the top. So how are we going to find out how far is in between here? Okay, there's a couple ways we could do it, right? I'm going to go ahead and I'm just going to say, well, we don't know what this is, but I know that this is the same distance as that and the same distance as that. So if this is 3, then this is 3, then this is 3. If this is 10, this is 10, this is 10, because it's the same variable. So I know that if I add x plus 4 plus x plus 4 plus x all together, what does it have to equal? Yeah, the distance up here of 14 feet all the way across. So I can go ahead and start with x plus 4 plus x plus 4 plus x all together equals 14. Now, can I put anything together that are the same? Absolutely, right? I have an x here, another x, and another x. So how many do I have all together? Perfection, 3 x's. And then I have a 4 and a 4, which is 8 equals 14. Now here we are just solving like normal. How do I get my 3x by itself? What do I have to get rid of? Right, that plus 8. How do you get rid of a plus 8? Subtract 8. So I need to subtract it from both sides of the equal sign. I now have 3x. That cancels. Equals 6. And what's happening between that 3 and the x? It's being multiplied, right? So what is the inverse operation? Awesome. Divide by 3 on the left side. Divide by 3 on the right side, so x would equal 2. So we know that each one of these is 2. So the answer, because the question said how far was in between, the answer would be 2 feet. Now, is there another way we could have solved this? Absolutely. So let's take a look. If this is 14 feet And I know that I have to take away the distance of each of the posters, right? So we can subtract 4 again, and that'll tell us how much is left altogether right here. So I'm going to go ahead and 14 take away 4 is 10, and 10 minus 4 is 6. So now I know we have 6 feet to work with, and 6 divided by the 3 spaces that we knew were the same is 2 feet each. Both ways work. This one's arithmetically, this one's algebraically. All right, next problem. It says your parents are redecorating the dining room and want to place 2 rectangular wall sconce lights that are 25 inches wide along a 10-foot wall. A 10-foot 8-inch wall, so that the distance between the lights and the distances from each light to the nearest edge of the wall are the same. And then it says design the wall and determine the distance. So on this one, we do have that drawing, right? So I'm going to go ahead and draw it right over here. So here's our wall. And we know that the total wall is 10 foot 8 inches. And we know that these wall sconce lights are 25 inches wide. Okay, so if we have it right here, this is going to be at 25 inches, and we have it 25 inches again. And we again need to know the distance on either side. So we want to know this, this, and this, and we know that they want to be the same. Okay. Now we have a problem here. What is the problem? Looking at our information right there and right there, what is the problem? We need to know how many inches are in a foot, because we have inches and feet, and that's not the same. Well, how many inches are in a foot? Good, 12 inches, right? Is 1 foot. That's a good sign that we know that. And our second thing that we know, would it be beneficial to convert to inches or to feet? Which one? Well, it's going to be better for us to go to inches, because if we go to feet, we're going to end up having fractions to work with. If we go to inches, we won't. Okay, so inches is going to be the better deal. So let's go ahead and let's take a look at what we got. So we need to change this right here to inches so that we can work with it. Okay, so how do we do that? Well, how do I find out how many inches is just in this 10 feet? Yeah, I'm going to take 10 times 12, because there's 12 inches in every 1 foot. And then what am I going to do? All right, we can go ahead and take the additional part is 12 times 2/3, because there's still 2/3 of a foot left. When I do that and I add them together, I'm going to get how many inches that whole wall is. So we have 12 times 10. Any number times 10, we just add that 0. And on the second one, we're going to be able to cross cancel, because this 12 is actually over a 1. So I can go ahead and say 3 goes into 3 once, and 3 went into that 12 4 times. And then we're back to 4 times 2 is 8. So we're going to get a total of 128 inches. Okay, now that we know that, what can we do? Yeah, we know that these 3 are going to be the same distance, but we have to first subtract that, right? So we're going to have 128 minus, well, what is 25 plus 25? Yeah, 50, just like 2/4. So when we subtract that, we get 78. And now we need to take the 78 divided by my 3 spaces. So 78 divided by 3. And 78 divided by 3 is 26 inches. Now, that's arithmetically. We didn't have any x's in there, right? All right, let the distance between a light and the nearest edge of the wall be x feet. Okay, so here is our design again. Here are our wall sconces, and this is x. So if this is x, how far is it in the center? X, and how about over here? Again, it's x, right? So our distance there is x. We still have 25, we have 25 inches here, right? And we had 10 feet and 2/3 of a foot up top, and then 25 inches. Now, what's different though about what we're doing here is it's telling us that we want to do it in feet. So we know that all of this info that we're going to do is now needing to be feet. So this 25 inches, we need to know how many feet that is. How am I going to change that? Well, since we know that 1 foot is 12 inches, 2 feet is 24. How many inches would be left? Yeah, 1 out of 12, right? So this is really going to be 2 feet, and then you would have 1 inch. Well, that's the same thing as saying 2 and 1 out of 12. So 2 and a 12th is going to be each one of those. So now it wants us to write that expression in terms of x for the total length of the wall. Well, we know that it's x plus 2 and 1/12 plus the middle x plus 2 and a 12th again plus the third x. And all together, okay, what can we put together? Now notice this also asked for an expression. So that's our expression, okay? Can we put any of this together? Absolutely, right? So let's go ahead and we can put our x's together. So let's take these x's. And we're going to go ahead and 3 x's. And then we can put our 2 and a 12th and 2 and a 12th together. So we get 4 and a 12th. And all together, what's that going to equal? Yeah, well, we knew what it was, right? We knew it was 10 feet, but then we knew it was also 2/3 of a foot. Well, if a foot has 12 inches, how do you get from 3 to 12? Times 4. So 2 times 4 is 8. So we know that 2/3 is 8/12 or 8 inches. Okay, so we know that this is going to be 2 and 8/12. Now we can actually just solve. Okay, so let's go ahead and get our 3x by itself. So what are we moving? Minus 4 and a 12th from both sides. So I now have 3x. Our mixed numbers cancel. Still have my equal sign. 8/12 minus 1/12 is 7/12. And 10 minus 4 is 6. And then in order to solve for x, to get x by itself, what's happening between the 3 and the x? Yeah, it's being divided, right? So we're going to divide this, multiplied, so we have to divide it by 3, and we're dividing this side by 3. In order to divide by 3, what do we have to do? To divide by a fraction, here's the tip. Yeah, keep change flip. So 12 times 6 is 72, plus 9, or plus 7 is 79 over 12. Change to multiply and flip to 1/3. As we multiply across, 79 over 1 is 79. 12 times 3 is 36. 36 goes into 79 2 times, which is 72. 36 and 36 was 72. And we have 7 left over 36. And that's wrong. This is a 6 because this is supposed to be 78, not 79. And 6/36 reduces to 2 1/6, which, if I go back here, if we do this and we look at how far that is, 12 and 12 is 24. So that's 2 and 2 twelfths, which reduces to 2 1/6. So it's the same thing. All right. Let's go and look at, maybe I skipped something. It says, what values of y makes the second equation true? Our second equation. And what that was, let me show you. It says, let the distance between the light and the nearest edge of the wall be y. Write an expression in terms of y for the total length of the wall. And when we look at our drawing, if we had our sconces like this, and it's just saying if this is a y, then this has to be y, and this has to be y, and these two were still 25s. So when we wrote our equation, we would have 1, 2, 3 y's plus 25 plus 25, or we would have 3y plus 50. Okay, so as we go over here to this next problem, we have that 3y plus 25 plus 25, and it equals to 128, which was our total length of our wall. And it says which one of these is going to be the solution. So what we're actually doing is we just take 3 times 24 and then add 50 to it and see if we get 128. Or take 3 times 25 plus 50. Do you get 128? Or is it 3 times 26 plus 50 equals 128? So go ahead and use your calculator, multiply it out, add 50, and see which one of those three actually is true. 2 are false, 1 is true. Double check by finding all 3. When you're ready, go ahead and unpause it. And then we're going to go ahead and take a look at example 1. And it says the ages of 3 sisters are consecutive integers. The sum of their ages is 45, and find their ages. And it wants us to use a tape diagram. First thing we have to look at, if things are consecutive, what do consecutive integers mean? Well, what they really mean is that we're just going in order. So if 1 is 1, the next one might be 2, and the third one might be 3. And then together, they're going to add up to 45. Well, we know 1 plus 2 plus 3 doesn't equal 45. But we know that consecutive means it's going in order. Okay, so, and it wants a tape diagram. So let's go ahead and I'm going to draw us a beautiful square. Oop, I don't want a red one. There we go. All right. Okay. As I draw, okay, there's my tape diagram, and I'm going to make 3 of them the exact same size, okay? The reason I'm making 3 the same size is I'm going to start out and think this is sister 1, okay? So if this is sister 1, she's the youngest, okay? She's going to be the youngest, and she's called X. So if she's X, and I know that consecutive means they go right in order, then I know sister 2, okay, this is sis 2, is however old sister 1 was, but she's how much older? 1 year, right? And then again, sister 3 is the same as sister 1 or sister 2. I can compare it to that one too. But how much older? Well, she's 2 older than the first sister, or 1 year extra compared to the second. And then we know altogether their ages are going to add up to 45. So I can go ahead and start solving. I know I can add these up, right? The first sister plus the second sister plus the third sister all together equals 45. Now take a look at that and see if it makes sense. However old the first one is, the second one is that same age plus 1 more, and the next sister is that same age plus 2 more. Let's go ahead and add them all together. How many X's do we have? Awesome. We have this X, this one, and this one, which is 3X. And how many whole numbers? We only have a 1 and a 2. And it's going to equal 45. We need to... Oh, that's not a 2. I have a 1 and a 2. That should have been a 3. I'm sorry, guys. All right, that's a 3. And so I'm going to subtract 3 from both sides. I now have 3x equals 42. What's happening between that 3 and the x when two things are next to each other? Multiply, right? So we have to do the inverse, which is divide. Divide by 3 on both sides. So my final answer, x is 14. That doesn't tell me all of them. Look at, find their ages. There's more. How many are there? There are 3 sisters, so this one is 14. How old is this girl then? Yeah, she's 15, and this girl is 16. So your answers should be 14, 15, and 16. Okay, go ahead and head back to the classroom.